Hey guys, today we're going to learn about conservation of energy. And this is the reason why we built those roller coasters, is so we can analyze the physics of how a roller coaster works using conservation of energy and be able to explain how our roller coasters work. So we have two main bullet points here. Let's write those down about conservation of energy before we get into the equation. So first thing is conservation of energy means energy is conserved. So it doesn't go up. Total energy doesn't go up and it doesn't go down. All right. The total amount of energy in the universe is a constant. It stays the same. All right. You don't get more energy in the universe out of nowhere or less going somewhere where you can't figure out where it went. The second point is we get energy, or an object gets energy only when it's transferred from another source. All right. So if you get more energy, that means something else outside of you must have lost that energy so that you can get it. Energy cannot be created or destroyed. You can't get new energy out of nowhere, and you can't lose energy and figure out, that something else must have got the energy you lost, the total stays the same, all right? So let's look at a few examples of this. Printed out this picture, and if you would just give yourself some quick sketches of each of these six things, and write down the caption for each of them. You could pause the video and do that right now. Okay, there we go. So let's look at them. So let's look at the example of a car. How does a car move and get what we call kinetic energy, movement energy? Well, it comes from the chemical energy that is stored in the gasoline, and the engine converts the chemical energy into kinetic energy. It doesn't get that kinetic energy out of nowhere. It gets it because the gasoline lost chemical energy. So it changes chemical energy, underline that, to mechanical, or in other words, kinetic. A tree changes energy from the sun